Okay, so we switched up from water waves to light waves, but they're all just waves, so it doesn't really matter. So if you remember watching Derek's video, when light comes through two slits down at the bottom, there is diffraction at each slit, and they act as a coherent source. In other words, the light is in phase. As it passes through the slits, it diffracts from this side, okay, meaning it bends, and it diffracts from this slit as well, meaning that it bends, and then you wind up with this nice fringe pattern that's cast on your screen, okay? Now, remember they talked about a central maximum, and if you look at this pattern, you would actually see that there is, in fact, a bright central maximum, and then there would be a dark fringe, and then another bright pattern here. So this is where you'd get constructive interference from both slits. You'd get destructive interference here, and then you'd be getting constructive interference here, and you'd also get a symmetrical pattern over on this side. Okay. Once again, just like water waves, remember when we said we basically treat these as if they're parallel, even though really they're not. The difference in the path length can be seen down here in this right angled triangle. So the sine of the angle to this first dark fringe is given when the path length is a half a wavelength different. And so this equation is no different than the one for water waves. Okay, good so far? Now, what about an area on the fringe where we have constructive, where we have a bright band? So now instead of a dark band, we're headed over here to a bright band. What's the path length difference going to be in this case? Is it going to be a half a wavelength? Is it going to be some multiple of a whole wavelength? Pause the video now and answer for yourself. Anyway, if you said, yes, it's going to be like this path length difference is going to be a wavelength, or possibly 2 wavelengths, or 3 wavelengths, you would be right. And so we can just change this equation a little bit. Instead of n minus 1/2, we can just do n lambda over d. We can even rearrange it if we like into d sine theta equals fringe number times the wavelength.